But what we know now is that the size of the cholesterol molecule matters a lot. In other words, the smaller the particulate size of cholesterol, the easier it is to cross into the arterial wall. Gets eaten by macrophage, and it forms something called a foam cell, which is essentially this foam cell process of oxidized cholesterol is what is the genesis of narrowing of the arteries, right? But again, we have to remember that cholesterol is called to the site of inflammation. So if you had two people, one with cholesterol of 100 and LDL cholesterol, and another one with cholesterol of 129, does the person with 129 have a higher incidence of cardiovascular disease? No. Does the person of 129 have a greater risk of a cardiovascular event? No, just because they have elevated LDL cholesterol. Now, if you start to look at other markers like C-reactive protein, which is a great marker for cardiovascular risk, if you look at triglyceride cholesterol ratio, because remember, triglyceride, is largely transported around the body on the surface of cholesterol. So if cholesterol was a tennis ball, the fuzzy yellow surface would be a fat, triglyceride. And if you remember from high school geometry, as the size of a sphere gets smaller, its surface area to volume ratio goes up.